Hello, everybody. Well, today we're going to be talking about waves and wave properties. Waves are actually all around us. They're not just in water. So with that, let's go ahead and just jump into this. All right. Sometimes waves do not need mediums. In pretty much any wave in the electromagnetic spectrum, which includes microwaves, radio waves, gamma rays, don't need a medium, which is a matter for something to flow through. Now, water waves, on the other hand, yes, do need a medium, thus the water. All right, so waves that don't need a medium to go through are electromagnetic waves, as we just discussed. Some waves must have a medium in order to move. These are called mechanical waves. So mechanical waves need a medium. Electromagnetic waves do not. All right, transverse waves. These are the waves we always think about. Waves in which the medium moves at right angles to the direction of the wave. AKA, boom, you have a trough and a crest. With the trough being at the low part, the crest being at the high part. So there's the crest, there's the trough. All right, compressional waves are longitudinal waves, waves in which the medium moves back and forth in the same direction as the wave. So whenever, these are also called, well, yeah, they are called compression waves. So whenever you see Aquaman out there going, woo, with that nice circle going off his forehead, these are the waves that we're talking about here, where they compress and they rarefact, where they elongate. So those are longitudinal waves or compression waves. So compression is where the particles go together, rarefaction is where they're spread apart. All right, wave properties depend on what type of energy is making the waves. So, wavelength, the distance between one point of wave and the exact same place on the next wave. That's wavelength. So, from the top of this wave to the top of the next wave is one wavelength. Frequency. How many waves go past a point in 1 second? Measured in hertz. All right, so that's frequency. How many waves go past a point? The higher the frequency, the more energy in the wave. All right, so 10 waves going past 1 second is 10 hertz. 1,000 waves going in 1 second is 1,000 hertz. It's 1,000,000 hertz. All right, amplitude is how far the medium moves from the rest position. Or it's the point from the crest to the trough. So, with the crest, the trough. So we have the amplitudes right there. All right. Remember, the close together, we have the compressions, rarefactions, and longitudinal waves. All right, wave speed. So speed depends on the medium in which the wave is traveling. So it's going to, waves travel, some waves travel faster in liquids and solids and gas. All right, so the way to figure out speed is speed equals wavelength times frequency, or V equals F times, yes, Greek letter for frequency. All right, we don't have to worry about these. We're not working on those. All right, changing wave directions. Reflection is when a wave bounces off a surface. So if a wave bounces off a surface, you can say it's reflected. Oops. Refraction. Waves can be bent. So if they're bent, they are refracted. So basically looking at the pencil there, the pencil is bending the light waves. That way, as it goes from the gas into the liquid, because the speed changes, therefore it looks like it's broken. All right, diffraction, the bending of waves around an object. And so this also depends on the size of the obstacle and the size of the waves, of course. All right, that's the end of that. Let's go on to electromagnetic waves here, where we just talked about those. All right, so we have the electromagnetic spectrum, which is all the electromagnetic waves rolled out from radio at the biggest over here to gamma rays at the smallest. As we'll find out later, as we go this direction from big to small, the energy increases because the frequency increases. See how many waves are here compared to one long wave here? A radio wave can be bigger, is usually bigger than a football field. All right, so let's go ahead and go on. All right, so electromagnetic spectrum is a complete spectrum of all forms of light. Yes, this is considered all light, but not all visible light. Visible light is only a little bitty tiny part of the electromagnetic spectrum. All right, so it consists of vibrations. All right, so consists of. All right, so we had the biggest waves as radio waves. And we have cell phone waves, microphone waves, radar waves, infrared rays, visible light waves, ultraviolet waves, X-rays, and gamma waves. All right, so here we have gamma, which are nuclear waves, ultraviolet from the sun, infrared, which are heat, microwave, and radio waves. And then we have cell phone or radar, visible light, and X-rays. All right, so speed, frequency, and wavelength. As we go from big to small, the speed increases and the frequency increases. So we've seen this formula before. All light waves travel at the speed of 3 times 10 to the 8th meters per second, which is aka the speed of light. All right, so this is as wavelength decreases, frequency increases. This is basically all this says. All right, and as the wavelengths get shorter, the energy gets higher. So radio waves have the longest wavelength, but they also have the least amount of energy and the least amount of frequency. See, all right, radio waves are about the size of buildings, and we get to microwaves about the size of humans. We get all the way here to gamma rays, though, they're the size of a nucleus and an atom. So they get very small compared to these huge ones here that are almost like a radio wave can be as big as a football field. So that's basically what this chart is showing. All right, radio waves. All right, so they have the longest wavelengths, include FM radio, AM radio, all the police radar, and your TV waves, which if you can still barely pick those up, those are also in the radio wave category. Now, devices we have, of course, radios, cell phones, and Bluetooth devices all operate on radio waves. So yeah, even your Wi-Fi. All right, microwaves. Only radio waves are longer, so microwaves are slightly shorter than radio waves. All right, used for communications and, of course, microwave ovens. Infrared waves. All right, see, these are detected as heat waves. These are also used in heat lamps. Those nice things to keep your food warm at the fast food restaurants and other restaurants. All right, so these have higher energy than microwaves, but still lower than visible light, which up next is visible light. All right, so everybody is familiar with the rainbow, which is Roy G. Biv, which is red, orange, yellow, green, blue, indigo, and violet, which is basically the visible light spectrum. All right, so, and they also go from low frequency to highest. Red has the lowest, of course, violet has the highest. All right, ultraviolet waves. All right, so they have higher energy than light waves, cause skin cancer and blindness in humans, and used in tanning beds and sterilizing equipment. So, yeah, we can shine a UV ray over everything and kill all the COVID on it, whatever surface we're shining, along with other microbes that are there. All right, so that's UV rays, which are slightly smaller than visible light. All right, so X-rays we have, which are high energy and used in the medical industry, of course, to give you X-rays. And too much of these can cause cancer. All right, after X-rays, we have gamma rays, which also brought us the Hulk. Wait, yes, gamma radiation did bring us the Hulk, but that's in science fiction, not in science fact. Let's see, these have the highest energy in the electromagnetic spectrum, and thankfully they are blocked from the Earth's atmosphere, keeping us from frying. Because if we were hit with a gamma ray burst, it would make it through the atmosphere and would kill us all. All right, so that concludes today's lecture. I'm going to attach two different worksheets to this. This is pretty much a straight up short unit, so this will probably be the only lecture you get, and then you'll have a test review, and then you'll have a quick test. So stay safe out there, enjoy everything, and I will talk to you all later. All right, bye-bye.